Good evening. Today in this session, I am going to continue with the explanation of questions based on projectile given in previous JEE main examinations. So, let us move on. We have completed up to 40 questions in the previous session. So, today let us start continuing with 41. See, projectiles A and B are thrown at angles 45 degrees and 60 degrees with the vertical, 60 degrees with the vertical, respectively from the top of a tower of 400 meters height. If their ranges and times of flight are same, ratio of their speeds. Actually, in that question, the self contradiction is their ranges and times of flight are equal is a wrong statement. So, as per the data, only times of flight are equal. So, here this is the wrong thing given in the problem. That is the reason why it was deleted in that session. So, here let us take the problem like this. Two projectiles are projected from the top of a tower with different angles of projection, but their times of flight are same. You are supposed to find the ratio of their velocities. See here, this is a tower of height h. A body is thrown with a velocity u at an angle. The key word is with the vertical. This angle is given as theta. Then the component of velocity along the vertical direction becomes u cos theta. So, it takes a parabolic path and it reaches the ground. So, in this case, if you consider the vertical motion, velocity is u cos theta in the upward direction. Acceleration is g, as it is in the downward direction, we take it as minus g. Vertical displacement on reaching the ground is s is equal to, this is the vertical displacement. As the vertical displacement is downwards, this is minus h. Time is capital T. Let us take time taken by the projectile to reach this point. So, here as s is equal to ut plus half at square, here minus h is equal to u cos theta t minus half g t square. So, let us make use of this equation in both cases. So, here in both cases as h is same, you can just equate u1 cos theta 1, t is also same, minus half g t square is equal to u2 cos theta 2 t minus half g t square, as t is same in both cases. So, here if you take that half g t square to the other side, you will be left with u1 cos theta 1 t is equal to u2 cos theta 2 t. As t's are same, they get cancelled. u1 cos theta 1 is equal to u2 cos theta 2. That is the hint. Now, u1 he has taken it as VA cos theta 1 is given as 45 degrees. That is equal to VB cos theta 2 is given as 60 degrees. So, here VA by VB is equal to cos 60 by cos 45, implies VA by VB is equal to cos 60 is half, cos 45 is 1 by root 2, this is 1 is to root 2, because this gets cancelled root 2 times. So, this is the problem. So, in this case, this is the main equation from which u1 cos theta 1 is equal to u2 cos theta 2. Okay, let us move on to the next problem. Look here, the initial speed of a projectile fired from the ground is u. At the highest point of its motion, speed of the projectile is root 3 by 2 u, time of flight of the projectile. At the highest point of the projectile, actually in case of a projectile, at the highest point, vertical component of velocity is 0. So, the speed is just equal to the horizontal component u cos theta. It is mentioned that u cos theta is equal to root 3 by 2 u. From this, cos theta is equal to root 3 by 2, angle of projection with the horizontal is 30 degrees. So, theta is equal to 30 degrees. Velocity of projection is u. What is asked? Time of projectile is asked. So, the formula for time of projectile is 2u sin theta by g. So, it is 2u sin 30 by g, because theta is 30 degrees. Sin 30 is 1 by 2, 2 and 2 gets cancelled, it is equal to u by g. So, in this problem, time of flight is u by g. Okay? So, let us move on to the next one. Look here. A projectile is projected with a velocity 25 meter per second at an angle theta with the horizontal. After t seconds, its inclination with the horizontal becomes equal to 0. At what point angle made by the projectile with the horizontal is 0? Yes, that is at the highest point. So, at the highest point, as the inclination with horizontal is 0, here it takes t seconds to reach that highest point. So, in case of a projectile, velocity is horizontal at the highest point. So, angle made by the projectile with the horizontal is 0. So, inclination of the projectile with the horizontal is 0 implies body is at the highest point. So, in this problem it is mentioned that time taken to reach that point is equal to small t. So, very obviously time of flight is this total time, time taken to reach the highest point is half the time of flight. Okay? If r represents a horizontal range, the value of theta from the data given. So, here range formula is r is equal to u square 2 sin theta cos theta by g. From that, using this formula you can find out theta and all those things. You can do that way, or otherwise we have this relation. I am writing different relations. Relation between height and time of flight is half g t by 2 whole square implies h is equal to gt square by 8. Because why we have taken t by 2 is time taken by the body to reach from this point to this point is half the time of flight. During that time of half the time of flight, vertical displacement is h. So, it is half g t by 2 whole square, or h is equal to g t square by 8, and 4h by r is equal to tan theta. Already yesterday we have seen the proof of it. 4h by r is tan theta. From these two expressions, r is equal to 4h by tan theta implies r is equal to 4 gt square by 8 by tan theta, from which r is equal to gt square by 2 tan theta. See, all these formulae we should have on the fingertips. Now, coming back to this problem again, look here. Look here, it is mentioned it is projected with a velocity 25 meter per second that at an angle theta with the horizontal. After t seconds, it is at the highest point. R represents the horizontal range. What is theta? So, from this equation, R is equal to G. Actually, from this, T is equal to 2T, isn't it? So, R is equal to G T square, G T square by 2 tan theta. This is the relation we got. Now, look here. See, from this expression, R is equal to G into 4T square by 2 tan theta. Or this and this gets cancelled, right? So, here tan theta is equal to 2G T square by R. The value of G is given as 10 meter per second square. So, tan theta, this is 20. So, tan theta is equal to 20 T square by R, but there is no option. So, cot theta will be R by 20 T square, or theta is equal to cot inverse R by 20 T square. Here the life is this one. If you remember the relation between the range and time of flight of a projectile as R is equal to GT square by 2 tan theta, it is a simple problem. It is just mentioned T is equal to capital T by 2, where capital T will be equal to 2T. That is what we have substituted in the problem. Okay? Now, look here. The ranges and heights for two projectiles projected with the same velocity of projection is same. Angles of projection are given as 42 degrees and 48 degrees with the horizontal. Ranges are R1, R2, heights are H1, H2. For a projectile, formula for the range is U square sin 2 theta by G, from which we have proved ranges are equal for complementary angles of projection for theta and 90 minus theta. Look here, the angles are 42 degrees and 48 degrees. The sum of these two angles is 90 degrees. So, they are complementary angles. When two projectiles are projected with same velocity at complementary angles of projection, ranges are equal. See here, ranges are equal in this case. Ranges are equal. And coming to the heights, what is the formula for maximum height reached by a projectile? U square sin square theta by 2G. If this is constant, H is proportional to sin square theta. As theta increases, sin theta increases and H also increases. As theta 1 is less than theta 2, H1 is less than H2. As theta 1 is less than theta 2, H1 is less than H2. So, the second option is correct for that problem. Okay? It is a simple thing. Now, let us move on to this problem. A helicopter flying horizontally with a speed v at an altitude h. Let this be the altitude from the ground. It is flying horizontally with a velocity v. Then a food packet is dropped from it to a man on the ground. What is the distance of the helicopter when the food packet is dropped from the man? look here. First, understand the problem. This is the height of the helicopter at the instant foot packet is released, and V is the velocity of the helicopter at the instant the foot packet is released. So, here the foot packet takes a parabolic path and finally it reaches the ground. There is a man here to receive that foot packet. So, in that question, what is the initial distance of the helicopter to the man? This distance is asked. If the horizontal distance is x, this distance of the initial position of the helicopter from the man who received the foot packet is s is equal to root of h square plus x square. Okay? So, h is straight away given. Now, how do you get x? So, x is equal to v into time taken by it to reach the ground. The time taken by it to reach the ground is square root of 2h by g, because vertical displacement of the foot packet is h here. So, t is square root of 2h by g. So, this is x. Substituting that in this expression, see, s is equal to square root of x square v square into 2h by g plus h square. So, what option? It is this option, isn't it? It is given that 2v square h by g plus h square is the way the option is given. That is the correct answer for that problem. Now, look here. The trajectory of a projectile is given as y is equal to alpha x minus beta x square. Alpha, beta are constants, x and y represents horizontal and vertical distances of the projectile from the point of projection. Angle of projection is theta. Then maximum height, angle of projection and maximum height respectively are. That's what is given in the problem. See here, y is equal to alpha x minus beta x square. Actually, in projectile, we have derived the relation between horizontal and vertical displacements as y is equal to tan theta x minus g by 2u square cos square theta into x square. Here, in place of tan theta, alpha is given. So, on comparison, tan theta is equal to alpha or theta is equal to tan inverse alpha. So, tan inverse alpha is the angle of projection. Next, you have to find out the maximum height reached. Look here. Actually, in the synopsis part, we have learnt like this. Y is equal to ax minus bx square in case of a projectile, then range is equal to a by b. We have proved that, and maximum height reached is equal to a square by 4b. And the time of flight relation also we have derived. Actually, h is equal to gt square by 8, which implies t is equal to square root of 8h by g, that is square root of 8 a square by 4b, from which 4b and this g is there. A square by 4b is in place of. So, this is t is equal to a square root of 2 by gb. These relations are very useful. They are the shortcut, very helpful shortcuts used in solving the problems, very easy based on projectiles. So, here already we have seen the proofs for all those things. So, in case of a projectile, the relation between horizontal vertical displacements is y is equal to ax minus bx square, from which range is a by b, maximum height is a square by 4b, time of flight is a square root of 2 by gb. Now, if you apply that concept here, maximum height reached is simply a square by 4 beta. So, this is the correct option. Theta is tan inverse alpha and maximum height is alpha square by 4 beta. So, you memorize these formulae. We will be seeing so many other previous questions based on those formulae, right? Okay, let us move on to the next problem. Look here. Starting from the origin at t is equal to 0 with the initial velocity u is equal to 5 j bar meter per second. It moves in xy plane with constant acceleration 10I plus 4j meter per second square. At time t, its coordinates are given by 20 meters and y0 meters. The values of t and y0 are, at time t, these are the coordinates. Okay, see, look here. Let us separately note down the data. Along x-axis, along y-axis, initial velocity is 0 because it has only y component. Along y-axis, initial velocity is 5. Acceleration along x-axis is 10. Acceleration along y-axis is 4. At time t, displacement along x-axis is given as 20. At time t, displacement along y-axis is given as y0. You are supposed to find t and y0. Those are the two things asked. From this, what relation connects them? S is equal to ut plus half at square. So, apply this to this. S is 20, u is 0. So, first term becomes 0. Half a is 10 into t square. 5, this 5 gets cancelled 4 times. T square is equal to 4 or t is equal to 2 seconds. So, we could find t here. Next, we need to find out y. From this data, if you apply the same equation, S is equal to ut plus half at square, y0 is equal to u is 5, t is 2 seconds, ut plus half, a is 4, t square is 2 square, that is 4. So, this is 10 plus 2 4s 8, it is 18 meters. So, the answer for that problem is, look here, see values of t and y0. T is 2 seconds and y0 is 18 meters. So, this is the correct answer for that problem. Okay? Now, look here, a projectile with same initial speed projected from the same point at 45 minus alpha, 45 plus alpha respectively, the ratio of their maximum heights. Actually, in yesterday's class, the same problem is given. I explained you that problem already. Let us move on to the next problem. A particle is moving in a circle of radius r with uniform speed, takes t to complete one revolution. If the particle is projected with the same speed, so velocity of projection of the particle is distance by time. 2 pi r by t, because it takes time t to complete one revolution. Distance travelled by it in one revolution is 2 pi r, distance by time is speed. So, velocity of projection is 2 pi r by t, angle of projection is given as theta, maximum height attained by it is equal to 4r. Angle of projection, we know the relation between height and range of a projectile is 4h by r is equal to tan theta. In this, maximum height attained by it is equal to 4r. See, what is asked? Angle of projection. So, in place of h, substitute 4r. Then tan theta is equal to 16r by range. Range is u square. So, what is 4h by r is tan theta. So, you are supposed to find tan theta here. So, this r and this r gets cancelled. Tan theta is equal to, just wait a second, let us go back to the question. Look here, a particle is moving in a circle of radius r with uniform speed, takes time t to complete one revolution if it is projected with the same speed. So, speed is equal to distance by time 2 pi r by t at an angle theta to the horizontal. Maximum height attained by it is equal to 4r, angle where r is not the range here. R is not the range here, it is radius here. That is the most important thing, right? Angle of projection is how much? So, maximum height attained by it is equal to 4r, where r is the radius taken here. So, what is the relation between, what is the expression for maximum height reached by a projectile? U square sin square theta by 2g. So, here maximum height is given as 4 times the radius of the circular path given. This is equal to, u is found to be 2 pi r by t, u square 2 pi r by t whole square into sin square theta by 2g, right? You are asked to find angle of projection. So, sin square theta is equal to 4r into 2g into t square by 4 pi square r square, right? Now, 4r and 4r gets cancelled. So, sin square theta is equal to 2g t square by pi square r. So, sin theta is equal to square root of, isn't it? From this, what will be sin theta? Sin theta will be equal to square root of 2g t square by pi square r. Or sin theta is this much, theta is sin inverse 2g t square by pi square r. The problem is so simple. Look here, I am explaining that once again. A particle is moving in a circular path of radius r with constant speed t, and completes one revolution in time t. With the same speed, it is projected at an angle theta. So, the speed is 2 pi r by t and angle of projection, leave it aside. So, maximum height reached by it is given as 4r, where r in the problem is the radius of the circular path. So, the maximum height formula for a projectile is u square sin square theta by 2g, we have substituted 4r in place of h here, 2 pi r by t in place of u here, and finally we could get the value of theta. That is the problem. Now, look here. This is an interesting problem. A body of mass 10 kg is projected at an angle 45 degrees with the horizontal. The trajectory of the body is observed to pass through a point 20 and 10. If t is the time of flight, its momentum vector at time t is equal to capital T by root 2, where t is the time of flight. Take the value of g as 10 meter per second square. What is asked in the question? You are asked to find out the momentum vector. So, momentum vector is m into ux I bar plus uy j bar. In case of a projectile, at any instant, velocity is horizontal component of velocity is u cos theta I bar, and velocity component along the vertical is u sin theta minus gt into j bar. That is the answer. So, look here. I am repeating the question. You are asked to find out the momentum of the vector at a given instant of time. Suppose Vx comma Vy are velocities of the projectile at that instant of time. Momentum at that instant of time will be mvx I bar plus mvy j bar. And for a projectile, velocity component along the horizontal remains constant throughout the journey. That is just u cos theta. The component of velocity along the vertical is u sin theta minus gt at any instant of time. So, if you want to find out momentum, m is given here, theta is given as 45 here, you have to find out u and t. To find u and t, this is the data given. The trajectory of the body is observed to pass through a point 20 and 10, okay, at the instant of time t by root 2. So, here what is the relation between x and y? Y is equal to tan theta x minus g by 2 u square cos square theta into x square. Okay. So, here if you substitute these two, y is equal to tan 45 is 1, theta is given as 45 here, tan 45 is 1, x is given as 20 minus g is given as 10, 10 by 2 is 5, x square is given as 20 square, as x is 20, x square by u square, we do not know, u square cos square 45 is 1 by 2. So, if you bring this 20 or if you bring this to this side, it becomes 5 into 20 square is 400 into this goes to the numerator into 2 by u square is equal to, if you take the 10 to the other side, it is equal to 10. So, 2 5s 10 and 10 gets cancelled. That implies u square is equal to 400, u is equal to 20 meter per second. Theta is given as 45 degrees. Now, you have to find out t. Small t is t by root 2. So, t is 2 u sin theta by g. So, t is equal to 2 u is 20, just now we found its value. Sin theta is 1 by root 2, g is 10. This and this gets cancelled, this gets cancelled. So, the time of flight is 2 root 2. So, t by root 2. So, t is equal to 2 root 2 by root 2, it is equal to 2 seconds. So, from that we could find out the time is given as 2 seconds. Mass of the object is given as 10 kg. You need to just substitute that value in this expression to find the momentum vector. So, let us substitute these values in this expression. Momentum is m into u cos theta, 20 into cos 45 is 1 by root 2, m u cos theta I bar, plus u is 20, sin theta is 1 by root 2, minus u sin theta minus gt, g is 10, t is 2, u sin theta minus gt, j bar. So, if you, this is 10 root 2 times, this is 10 root 2 times, if you expand this, 10 tens are 100 root 2 I bar momentum, plus 10 into 10, 100, 100 root 2 minus 10 into 10 into 2, 200 j bar. This is the momentum at that instant of time. So, which option is correct? 100 root 2 I plus 100 root 2 minus 200 j. This option is perfectly correct. So, I repeat that problem once again. You are supposed to find out the momentum vector of a projectile at any instant of time t. So, momentum vector of a projectile has x component and also y component, m into u cos theta I bar plus velocity at any instant of time along the vertical becomes u sin theta minus gt j bar. So, that is the most important part of the problem. This m into vx I bar plus vy j bar at any instant of time, horizontal component of velocity is u cos theta and vertical component of velocity is u sin theta minus gt. Okay. So, here from the other data given, we could get the values of u and t. Theta is already given, from which we could solve that problem. Let us move on to the next problem. A projectile is launched. A projectile is launched at an angle with the horizontal with a velocity 20 meter per second. After 10 seconds, its inclination with the horizontal is beta. At time t, angle made by the projectile with the horizontal is beta, then tan beta. See, this is a projectile at any instant of time, its velocity is along this, x component is Vx, y component is Vy, and angle made by the projectile with the horizontal is given as beta, from which tan beta is equal to opposite side is Vy and adjacent side is Vx. So, tan beta is equal to Vy is u sin theta minus gt, Vx is u cos theta. In the previous problem also we have used that. Now, look here, let us substitute. Tan beta is equal to u is 20. It is projected at an angle alpha. 20 sin alpha minus G is 10 after 10 seconds. G is 10 after 10 seconds divided by U is given as 20 cos alpha. So, this is sin alpha minus 100 by 20 is 5 divided by cos alpha, implies tan beta is equal to sin alpha by cos alpha is tan alpha. 1 by cos alpha is secant alpha. So, tan beta is 5 tan alpha minus 5 secant alpha. So, tan alpha minus 5 secant alpha is the answer. It's a beautiful problem, isn't it? Very simple, but it's a new problem. Okay, let's move on to the next one. Look here, a shell is fired from a fixed gun with an initial speed u such that it hits the target on the ground at a distance r. T1, T2 are the values of times taken by it to hit the target in two possible ways. So, here the target is at this point, so it can reach this target at two different angles of projection. One angle of projection is theta, another angle of projection is 90 minus theta, because the range is same for two complementary angles of projection. So, one angle is theta, then the other angle of projection will be 90 minus theta. Then the T1, T2 are values of times taken to hit the target. So, we call the time taken by the projectile to reach this point is time of flight. So, times of flight are given as small t1 and t2. So, in the second case time of flight is t2, first case it is t1. What is asked? The product of t1, t2. So, time of flight is 2u sin theta by g. So, 2u sin theta 1 by g. Product of t1, t2 is asked into 2u sin theta 2 by g. So, look here, it is just to take this 2 by g outside, 2 by g outside, you are left with u into u square 2 sin theta 1 is theta, theta 2 is 90 minus theta. Do you understand? So, this is 2 by g u square 2 sin theta, sin 90 minus theta is cos theta. So, it is 2 sin theta cos theta is sin 2 theta. So, we know u square and another g is also there because we have taken one g here. And what is this u square sin 2 theta by g? Range of a projectile. So, it is 2 by g into r, that is the product of times of flight. Is it okay? So, I just repeat that question again because it is a very important model. Look here, range is same for angles of projection theta and 90 minus theta. For this, if times of flight are t1 and t2, 2u sin theta by g is time of flight for one, 2u sin 90 minus theta, that is cos theta by g, that is time of flight for the other. This is, if you take this 2 by g as common factor, so just as a outside 2 by g u square 2 sin theta cos theta is sin 2 theta by g, this is equal to range. So, T1, T2 is equal to 2 by g into r. very important relation. Now, exactly this is also, and most of the students, if they have thorough practice, these relations they will be remembering that, not memorizing, because of thorough practice they remember. That is T1 T2 is equal to 2R by G. Similarly, maximum heights reached here. Look, two particles are projected from the same point with the same speed such that they have the same range. Both of them are projected with you at angles theta and 90 minus theta. Angles of projection are theta and 90 minus theta. Maximum heights reached are H1, H2. So, if you look at the options, which of the following is correct? So, we have to find out the product of their maximum heights. In case of a projectile, maximum height reached is u square sin square theta by 2g. H1 is u square sin square theta by 2g. H2 is u square sin square, angle of projection in the second case is 90 minus theta by 2g. So, this is u square sin square theta by 2g into u square sin 90 minus theta is cos theta, cos square theta by 2g. So, let us take this as common factor, not common factor outside, just u square by 2g, u square sin square theta, u square sin square theta, cos square theta by 2g is remaining. Okay, so look here, r square, this is H1 into H2, r square is u square sin square 2 theta by 4g square. Actually, you need not do this also, just you keep it aside, and r square is u square sin square 2 theta by g. Look here. So, from this what can we say? Let us substitute sin square theta, sin 2 theta is equal to 2 sin theta cos theta, or sin theta cos theta is equal to sin square 2 theta by 2. So, that not sin square, sin 2 theta by 2. So, that implies sin square theta cos square theta is equal to sin square 2 theta by 4. So, sin square theta cos square theta is, let us write like this, u square by 2g, u square by 2g, sin square theta cos square theta is sin square 2 theta by 4, sin square 2 theta by 4. Now, u square sin square 2 theta by 4g square. So, look here, u square sin square theta by u to the power of 4, isn't it? U to the power of 4 sin square 2 theta by 4g square, 4g square. Till then it is equal to range. So, H1, H2 is equal to r square by 4. This is r square. So, H1, H2 is equal to r square by 4, or r square is equal to 4H1, H2. That is the answer. But actually, we solve this as r is equal to 4 root H1, H2. If you know that relation, it is so simple. R square is equal, this is just a minute. Let us come back to this once again, isn't it? So, here let us go back to this problem. From that relation, we know that relation already from derivation, then r square is equal to 16 H1 H2 must be the correct answer. Look here, let us prove that. R is equal to u square sine 2 theta by g. H1 H2 under root is equal to u square sine square theta by 2g, u square cos square theta by 2g under root. So, here this is u square by 2g into sine theta cos theta. Okay. So, from this expression what do we get? This is u square by 2g into sine 2 theta by 2, right. So, H1 H2 is equal to u square sine 2 theta by g is equal to range. So, root of H1 H2 is equal to r by 4, or r is equal to 4 root H1 H2, from which r square is equal to 16 H1 H2 is the correct option. This is the simplest method for that problem. Okay. Now, let us move on to the next problem. Look here. A particle is projected at an angle 30 degrees from the horizontal at a speed of 60 meter per second. Height traversed by the particle in the first second is h0. h0 is the height traversed by it in the first second, and height traversed in the last second is h1, is in the last second. Take g as 10 meter per second square. So, a particle is projected at an angle 30 degrees from the horizontal. See here, u is given, theta is given. So, height is vertical displacement of the projectile. What is the formula for the vertical displacement? Y is equal to u sin theta t minus half gt square. See here, in the first second, when t is equal to 1, vertical displacement is h0. U is given as 60, theta is given as 30, sin 30 is half, t is given as 1, g by 2 is 5, t square is 1. So, this is h0 is equal to 30 minus 5, that is 25 meters. So, vertical displacement in the first second is 25 meters. H1 is vertical displacement in the last second. It is very simple. Last second of ascent is first second of descent. During the vertical motion, as initial velocity along the vertical is 0, displacement is half gt square. If t is 1, displacement is 5. So, h1 is 5 meters straight away. You are asked to find the ratio h0 by h1. What will be its value? h0 by h1 is equal to 25 by 5. It is 5. Ratio is 5. Okay. So, I will stop here for today. I will continue in tomorrow's session with the remaining problems. Okay. You have to practice them by yourself once again. Whenever you get a doubt, you can go back to that particular video and you can clarify your doubt. Only then it is going to be helpful. Okay. Thank you and bye-bye.